The second law we're going to be concerned with is called the product rule of probability. The product rule of probability is also known as Bayes' rule or Bayes' theorem, and we're going to be using any of these terms interchangeably. The statement of the law is shown right here. It says that the probability of A and B is the probability of A given B times the probability of B. Of course, you can write this law in many different ways. In particular, you can write it swapping A and B. So the probability of A and B given I is the probability of B given A times the probability of A given I. Nothing fancy here, we're just swapping A and B. But there is also another way that's very popular, and this is the following. The probability of A given B is the probability of A and B divided by the probability of B. Of course, this just comes from the first equation by rearranging the terms. Take a little bit of time to meditate on this. Let's use the Venn diagram to develop some intuition about Bayes' rule. The rule says that the probability of A given B is the probability of A and B divided by the probability of B. The probability of A and B corresponds to this area right here, and the probability of B is of course represented by the red area. So the probability of A given B, therefore the probability of A given B is the ratio of the area of the intersection of A and B divided by the area of B. Now let's apply Bayes' rule to our box example. Let R2 be the sentence the second ball we draw is red, and we want to find the probability of R2 being true given that B1 is true. So the probability that we draw a red ball on the second draw, given that the ball we drew in the first draw was blue one. So we had 10 balls, 6 red and 4 blue. Since B1 is true, we know that we now have 6 red balls and 3 blue balls. Therefore, the probability of drawing a red ball, given that we have drawn a blue ball in the first draw, is 6 divided by 9. 6 red balls, 9 balls in total. Now we're going to consider a joint event, the event that we first draw a blue ball followed by a red ball. This event can be written as B1, R2. So blue ball in the first draw and a red ball in the second draw. And we have to use the product rule to find this probability. It is going to be the probability of R2 given B1 times the probability of B1. Of course, we know both these probabilities, so we can plug in the estimates and find them. The first one is what we found just before. It's 6 divided by n, and the other one was 0.4 if I remember correctly. So you get 0.26. Notice that in this example it was actually easier to find first the conditional probabilities and then the probabilities of the more complex event.